Same question, same model, two completely different answers. The one on the right checked real documents before it answered. That's RAG, and if you've used Cursor, Copilot, or Perplexity, you're already relying on it without ever seeing it happen. By the end of this, you'll know exactly what happens between typing a question in your editor and getting an answer that's actually about your codebase, and why context windows the size of entire books still haven't made this technique obsolete. Every language model has a hard limit. It learned from data up to a certain date, and after that, it knows nothing. Ask it about your company's internal docs, and it can invent an answer. Ask it about something that happened yesterday, and it can guess. Fine-tuning doesn't fix this. Fine-tuning changes how a model behaves, not what it currently knows. So what if, before answering, the model could actually go look something up first? RAG stands for Retrieval Augmented Generation. The term comes from a 2020 paper by Patrick Lewis and a team at Meta AI. Instead of relying only on what the model already learned, you retrieve relevant information first, and inject it into the prompt before the model ever generates a response. A question comes in, the system searches for relevant documents, bundles them with the question, and sends all of it to the model, so the answer comes back grounded in something real. Simple to describe. The complexity is entirely in making that search actually work. Step 1 happens before any question is ever asked: indexing. You take your documents and split them into smaller pieces, called chunks. A 100-page document doesn't fit in a prompt, so you need just the relevant slice of it. Each chunk passes through an embedding model, which turns text into a vector, an array of numbers that represents its meaning. Those vectors go into a vector database, Pinecone, Vector, Chroma, among others. And here's the part that makes the whole thing work. Vectors with similar meaning end up close together in that space. When you ask a question, that question becomes a vector too, using the exact same embedding model. The vector database compares it against every stored chunk and finds the closest matches, the top few chunks whose meaning is nearest to your question. Those get pulled out and injected into the prompt, right alongside your original question. Now the model has your question and the actual source material in front of it, and generates an answer grounded in that context instead of guessing from memory. Index, retrieve, generate, that's the full pipeline. And like any pipeline, the final answer is only as good as the weakest stage in it. Coding agents like Cursor, Claude Code, and Copilot all run on this. When one of them reads your codebase to understand context before suggesting code, that's retrieval, live. Cursor specifically breaks your code into meaningful chunks, functions, classes, logical blocks, embeds each one, and stores them in a vector database, syncing every few minutes as your code changes. Ask it a question, and it embeds your query, finds the closest matching code, and pulls in exactly the files that are actually relevant, instead of guessing at your project structure from nothing. Perplexity and Google's AI overviews use the same idea for the web: search, retrieve passages, generate an answer with sources attached. Support chatbots that answer from a company's documentation are doing this too. If a model needs to know something outside its training data, there's almost certainly a RAG system underneath it. If it's this useful, here's the question that actually matters: why doesn't it always work well? The first failure point is bad chunking. Cut a document in the wrong place, say in the middle of a sentence, and the embedding represents something incomplete, so the search pulls back garbage. Chunks too large lose precision. Chunks too small lose context, and the right size genuinely depends on the kind of document. The second failure point is retrieval pulling back chunks that sound related but aren't actually useful. Semantic similarity isn't perfect, and similar sounding words don't always mean the same thing. The third is the model still getting it wrong even with the right chunks in front of it. A 2023 Stanford study found that models are measurably worse at using information buried in the middle of a long context than information at the start or end. And on top of all of that, there's latency. Every vector lookup, every embedding call, every re-ranking step adds time, which adds up fast in anything that needs to feel instant. Fine-tuning changes how a model behaves. RAG changes what information it can access. Need a specific tone or output format. Fine tuning. Need it to see private or constantly updated data. RAG. In practice, plenty of real systems use both. And context windows keep growing. Hundreds of thousands of tokens, sometimes over 1 million. So does RAG still matter? Yes, dumping entire documents into a giant prompt can work, but it's slower, more expensive, and runs straight into that same lost-in-the-middle problem. A well-built retrieval step hands the model only what's actually relevant, instead of everything and hoping it finds the right part. So here's the actual decision. If a model needs to sound a certain way or follow a specific format, that's fine-tuning. If it needs facts it was never trained on, your files, your docs, this morning's data, that's retrieval. If you need both accuracy and access to fresh information, the systems that work best today combine them: RAG to find the right material, a re-ranker to filter it further, and a well-tuned model to actually write the answer. Whenever you use an AI tool that reaches into your files or your documents and answers with something that's actually true about them, you can be confident there's a retrieval system doing the real work underneath. Same discipline as reading a stack trace instead of guessing what broke. The exact instinct you shouldn't use useEffect on this channel applies to a completely different layer of the stack.